Okay, let's look at how to turn word equations into balanced chemical equations. So the first thing that you're going to need is your tan chart to do this. And so the first thing you're going to do is look up aluminum metal and find the symbol for that, Al. Okay, now one thing about it is any element by itself has a charge of 0, but for the sake of doing this, we're going to look up and look at the charge of what aluminum would be if it was with something, and that's 3 positive. And that's going to react with copper 2, so you're going to have to look up the charge of copper 2, or just know that the Roman numeral means 2 plus, and chloride is 1 negative, and if the charges aren't opposite but equal, you need a crisscross, so we get CuCl2. We're going to draw an arrow. Now, I don't know if you recognize this, but this would be a single replacement reaction. When you have like a positive with a positive negative, well, a positive will replace a positive. So what's going to happen is the aluminum would go with the copper. So you'd go aluminum, or not with copper, with the chloride. So you'd go aluminum 3 positive, chloride 1 negative, and then you would do the crisscross, AlCl3, and then copper goes by itself. Now with a single replacement reaction, it always kind of goes like this, is you have something by itself, the charge that it is, that this positive will only replace another positive, and then the other one will go by itself, the one that gets replaced. Okay, let's balance this equation. So I like to draw a line right down the middle, list the elements, aluminum, copper, chloride or chlorine, aluminum, copper, I like to list them in the same order, chlorine. Okay, let's count. 1 aluminum, 1 copper, 2 chlorides. 1 aluminum, 3, or no, I'm doing copper, 1 copper, 3 chlorides. That's why I like to list them across. Now, 2 and 3. Okay, they're not the same, so we got to make them the same number. Well, 2 and 3, the lowest number they go into is both 6. So I'm going to make this 6, but what number do I got to multiply times 2 to get 6? That number will be 3. So I'm going to put a 3 in front, and that's going to change my chlorides to 6, but that's going to change my copper to 3. Okay, now I'm going to make this chloride over here. What number do I got to multiply times 3 to get 6? That's going to be 2. So that's going to make this chloride 6, but now it made my aluminum 2. I know that kind of looks like a 3 there. So there we go, 2. Now if we look, the copper, or the chloride is 6. The chloride is 6. This copper is 3. This one is 1. So I'm going to write a 3 there. That will fix that. Now this aluminum's 2. I need this aluminum to be 2, so I have to write a 2 there. Okay, the next one. Lead 2 nitrate. So we're going to write the formula. Lead 2 positive, nitrate, NO3 1 minus. I'm going to crisscross, PbNO3 2, reacts with sodium, Na 1 positive, bromide 1 negative. I'm looking up the charges on the tan chart. If the charges are the same, you don't have to crisscross. Okay, now this is what's called a double replacement. Basically, positives and negatives, positives will trade places with each other, kind of. And so this positive will go with that negative, and this positive will go with that negative. However, when writing formulas, the positive is always written first. So I'm going to go lead 2 positive, bromine 1 negative. I'm going to crisscross them, PbR2, plus sodium, which is a positive. See how I'm writing the positive first, even though it comes second over here, is going to go with the nitrate, which is 1 negative, so NaNO3. Okay, now I'm going to balance the equation. So I'm going to list the elements. So I've got Pb. Now a shortcut way is nitrate is NO3 here. It's over there. So if the ion, the polyatomic ion shows up on both sides, you can just list that instead of nitrogen and oxygen. It's faster. sodium, and then bromide. So lead, nitrate, sodium, and bromide. Okay, let's count. 1 lead, 2 nitrate, 1 sodium, 1 bromide. 1 lead over here, 2 bromides, 1 nitrate, 1 sodium. All right, I see the nitrates are not evened up. 2 nitrates here, 1 over here. So I'm going to write a 2 right there. That gives me 2 nitrates, but that also gives me 2 sodiums. Now, I notice the sodiums, 2 sodiums, 1. So I'm going to write a 2 over here. That gives me 2 sodiums and now 2 bromines or bromides, because that 2 goes all the way through. Now everything is the same. That equation is balanced. Okay, the next one. Zinc metal with oxygen gas. So zinc plus O2. Remember, look at the bottom of the tan chart. When you see the word gas, look at the bottom middle of the tan chart and see if it's a diatomic element, and O2 is. Okay, so these, you only got 2 things, so the only thing that can happen, this must be what's called a synthesis reaction. So zinc is +2, oxygen is 2 minus. The charges are equal but opposite, so don't crisscross. So it just makes ZnO. All right, so let's count. We got zinc, we've got oxygen. We have zinc, we have oxygen. 1 zinc, 2 oxygen. 1 zinc, 1 oxygen. Okay, the oxygens aren't even, so I'm going to have to write a 2 here. That gives me 2 oxygens. That also, though, now gives me 2 zincs. So now I got to come back and fix the zinc by writing a 2 here. Okay, that gives me 2 zincs. All right, I'm going to skip down to this bonus one. Okay, this one wasn't on your worksheet, but it would be a good one to know how to do. So propane is C3H8 plus O2, oxygen. Now, the combustion of a hydrocarbon, you need to memorize this, always makes 2 things. It always makes CO2 and H2O. You just got to memorize that. There's no charges or anything. You just got to memorize. The combustion of a hydrocarbon, something with carbon and hydrogen and sometimes oxygen in it, makes CO2 and H2O. Got to memorize that. Let's balance. C, H, O. C, H, O. Let's count. 3 C's, 8 H's, 2 O's. 1 C, 2 H. Be careful here. 2 plus 1, 3 O's. Okay, the way to balance these is always to do it in this order. First, balance the carbons. Let's do that. 3 carbons. Let's write a 3 here. So that makes that 3 carbons, but now 3 times 2 makes that 6 oxygens. Always do the carbons first. Second, fix the hydrogens. Okay, we've got 8 hydrogens here and 2 over here. So I've got to put a 4 right there. That gives me 4 times 2 is 8 hydrogens now. But that gave me 4 oxygens here plus 6 right here. 3 times 2 is 6. Okay? And so I actually think I had 7 over here last time, so this 6 isn't right. 6 plus 4, that gives me 10 oxygens. Okay, I need 10 on this side because the carbons and hydrogens are okay. Let's fix the oxygens. So that would be a 5 there because 5 times 2 is 10. Okay, always do it. First carbons, second hydrogens, third do the oxygens. That's because the oxygens are usually in more than one spot over here, and it's just easier if you do it that way. All right, that's it for that video. You should try to see if you can do the rest of this video.